Hello, my name is Bodie Hughes, and this is my project for the Newton's laws. So, where the laws came from is a man named Sir Isaac Newton sat under a tree and an apple fell on his head, and so he thought, well, why did it fall? He considered that there might have been a force that caused it to fall, and so he researched into that and he discovered his three laws. He took ideologies of other scientists and put them together to form these laws. And so in this video, I will demonstrate them and explain them. So you've got the first law, the law of inertia, and what it states is summarized, shortened. I'll just say the original thing. An object in motion will stay in motion unless acted upon by an unbalanced force, and an object at rest will stay at rest unless acted upon by an unbalanced force. So to demonstrate that, I've got this soccer ball with its tag still on it, and so currently it is not moving because nothing is acted on it. But if you kick it, it moves, because the unbalanced force of kicking it moves it. And so that's how it goes. And as you can see, it stopped and it's back in its resting state. And the other part of Newton's first law states that an object in motion will stay in motion unless acted upon by another force, an unbalanced force. So what was that force? Well, you've got the air, which is made up of tiny atoms and molecules, which even though you can't see them, they're there, and there's so many of them that it's enough to cause something to happen to the ball, and so it slowed it down. And it didn't really go in the air, so it was on the ground, and the ground is rough, so it was it was causing friction, which is there to stop a moving object from moving. And so it stopped. So I'm going to go recover that because it's also going to be used in the next part of this. I've recovered it. So now we're going to move on to the second law. And so the second law, what it says is an object with more mass requires more force to affect it. So this ball doesn't have that much mass because it's just a tiny air-filled ball. Whilst this, on the other hand, is a stone brick, which is heavier because this is a small air-filled piece of rubber with a mesh thing over it, and this is, well, a rock. So I'm going to kick them both and see what happens. So first, let's kick the brick. As you can see, it doesn't really move that much. But you kick the ball, on the other hand, and it goes farther. So, when I applied an equal amount of force on them, this obviously didn't move as far as that. That moved all the way over there, and this one started about right there. And so it barely moved. That one over there started about right here. So as you can see, it's traveled a farther distance because it had less mass, and so the force of kicking it had much more effect on it because of its lesser mass than kicking this. Pretty simple. And so let's retrieve this back over here. And the next thing is action and reaction. Now, the reason why kicking a ball causes it to move is because the force of you kicking it acts on it. That's an action. And so therefore, it propels the ball. And if you take the ball and you toss it on the ground, it bounces up a little bit. because whilst it pushes on the earth, and therefore the earth pushes back. And that's why it goes up in the air. Because gravity pulls it down, it hits the earth pushes on it, and it goes back into the air for a brief moment. Now, if I were to pick this up, excuse me, heavy one. If I were to drop this stone, it doesn't bounce. Now, why is that? Well, it's because, as I said earlier, it has more mass. So it hits the earth, and it pushes on it, but since it wasn't dropped from a high height, and it takes more gravity to pull it down to earth, it doesn't have enough, it isn't small enough, it doesn't have a little amount of mass, it has a large amount of mass, and so it doesn't go back up. And so yeah, and when it comes, and so basically retracing back to what we've covered in this video. So inertia, if something is unmoving, it tends to not want to move, so it just stays there because there's static friction, I believe that's what it's called, and it prevents an unmoving object from moving on its own, which requires a force. And then regular friction stops a moving object from moving. That's why if you were to kick something in space up there, where there is nothing to stop it, there is no air to stop it, there is no ground to stop it, then it would just keep going and going because there's nothing to stop it. There is no friction, and so nothing is pushing it back, and so nothing is stopping it. Whilst on Earth, we have gravity, friction, ground, and air, and multiple objects, and so when I kick it, eventually, it stops. So, we're covering this yet again. And then going back to the law of where Newton's second law, this is a tiny air-filled ball and this is a stone brick. So if I apply the same amount of force to them in kicking them, again it goes farther, and again doesn't do much to that. And then you've got Newton's third law, where every action has an equal and opposite reaction. That is how rockets work. The rocket's propulsion forces on the ground, and so therefore the ground forces back on it and lifts it into the air, and then it makes it to space. And from there, if there's nothing to stop it, then it doesn't stop. Because there's no air, there's no friction, there's only, a void. So the only thing and so if this were to be kicked in space, then it wouldn't stop as I've showed you, like it does here on Earth. It would just keep going unless it hits something that stops it from moving. And when it comes to the third law, say, throw it at this tree, it's going to bounce off. So, bounced off because it pushes on the tree, and the tree pushes back on it. So, that's how it works. And also, it the ball and the stone pushes just a little bit on the earth, and it pushes it just a tiny, immeasurably small little distance. But since the ball has less mass and the stone has less mass, than the Earth, you don't really realize it. You only realize either thing moving. And so I've reached 10 seconds, and so that concludes my project. Goodbye.